In section 7.1, we're looking at graphing and functions. We begin this section by looking at René Descartes' rule of a rectangular coordinate system, or the Cartesian coordinate system. Descartes used two number lines that intersect at right angles at their 0 points. The horizontal number line is the x-axis and the vertical number line is the y-axis. The point of intersection of these axes is their 0 points, called the origin. Positive numbers are shown to the right and above the origin. Negative numbers are shown to the left of and below the origin. The axes divide the plane into 4 quarters, called quadrants. The points located on the axes are not in any quadrant. So you can see we start in the top right-hand corner with quadrant 1, and then we move in a counterclockwise direction. So we start at quadrant 1, we go to the left for quadrant 2, then we go down to quadrant 3, and then go down to the right to quadrant 4. Each point in the rectangular coordinate system corresponds to an ordered pair of real numbers x, y. Let's look at the ordered pairs 5, 3, and 3, -5. The first number in each pair, called the x-coordinate, denotes the distance and direction from the origin along the x-axis. The second number in each pair, called the y-coordinate, denotes the vertical distance and direction along the y-axis or along the y-axis itself. The figure shows how we plot or locate the points corresponding to the ordered pairs -5, 3, and 3, -5. So let's go ahead and look at -5, 3 first. So because our x is -5, that means we are going to start at the origin and we move 5 units to the left since it's negative. Once we reach that point, we look at the y-coordinate, which is a +3. So we're going to move up 3 units. And once we get to that point, that is our coordinate or our point on the graph for -5, 3. Let's go ahead and look at 3, -5. So starting again at the origin, because x is a +3, we're going to move 3 units to the right. And from there, we have a y-coordinate of -5. So we're going to move down 5 units. And that's where our point would be on the graph. So order, as you can see, is very important because we got 2 very different points on the graph for each of these ordered pairs. Let's go ahead and plot the following points. The first one is -3, 5. And so that means in the x direction, we're going to go to the left 3 units, and then we're going to go up 5 units. The letter that's next to the ordered pair is just to make it easier to distinguish it on the graph once we're done plotting. So we're going to go to the left 3 units, and then we're going to go up 5 units. And so we have A, let's go ahead and look at B. We have 2, -4. So we're going to go in the +2 direction first on x, which means we're going to go to the right 2 units. And then we're going to go down 4 units. So, to the right 2, and then down 4. Let's go ahead and look at C. We have 5, 0. And so we're going to go in the positive 5 direction for X. We're going to go to the right 5 units. And then we're not going to move at all for Y because it's 0. So we're just going to stay there. We're not moving in that direction. So all we're doing for this point is moving 5 units to the right. Let's go ahead and look at D, which is -5, -3. So we are going to move to the left 5 units, and then we're going to move down 3 units. Let's go ahead and look at E. This time we have 0, 4. So we're not moving anywhere in the X direction or the horizontal direction, but we will be moving up 4 units in the Y direction. So from the origin, we're just going to move up 4 units. And then the last one, which is 0, 0. This means that from the origin, we're not moving in the X direction, and we're also not moving in the Y direction. We're just staying right at the origin. A relationship between two quantities can be expressed as an equation in 2 variables, such as y equals 4 minus x squared. A solution of an equation in 2 variables, x and y, is an ordered pair of real numbers with the following property. When the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we obtain a true statement. The graph of an equation in 2 variables is the set of all points whose coordinates satisfy the equation. We can generate as many ordered pair solutions as desired to an equation by substituting numbers for x and then finding the corresponding values for y. The graph of an equation in 2 variables is the set of all points whose coordinates satisfy the equation. One method for graphing such equations is the point plotting method. First, we find several ordered pairs that are solutions of the equation. Next, we plot these ordered pairs as points in the rectangular coordinate system. Finally, we connect the points with a smooth curve or line. So let's go ahead and take a look at example number 2. We have y equals 4 minus x squared, and we want to graph it. And we're selecting integers for x, starting with -3 and ending with 3. So our values of x that we're allowed to have, we're starting with -3, and they're integers. So -3, -2, -1, 0, 1, 2, and 3. Now what we're going to do is we're going to plug those x values individually into our equation, which is y equals 4 minus x squared. So let's go ahead and start. We have 4 minus -3 squared using order of operations. We're going to do our exponent first, and so we end up with 4 minus 9, which is negative 5. And so the ordered pair for this point, or for this x value, is going to be negative 3, comma, negative 5. We're going to do the same process with the rest of our x values. So we have 4 minus negative 2 squared, and that's 4 minus 4, and that's 0. And so the ordered pair for this one is going to be the point negative 2, comma, 0. Plugging in negative 1, we have 4 minus negative 1 squared, and that's 4 minus 1, which is 3. And so the ordered pair is negative 1, comma, 3. Plugging in 0, we have 4 minus 0 squared, which is just 4 minus 0, or we get 4. And so we end up getting 4, comma, 0, 0, comma, 4 as our ordered pair. Plugging in 1, we have 4 minus 1 squared, or 4 minus 1, which is 3. And so we get the point 1, comma, 3. We have 4 minus 2 squared, which is 4 minus 4, or 0. And so we get the point 2, 0. And the last one, we have 4 minus 3 squared, which is 4 minus 9, which gives me negative 5. And so we get the point 3, comma, negative 5. And so now that we have all of our points here, we just want to plot them on the graph and then connect them. So we have negative 3, negative 5. So go left 3 units and then down 5 units. We have negative 2, 0. So we're just moving to the left 2 units. We have negative 1, 3. So to the left 1 and then up 3 units. We have 0, 4, which just means that we move up 4 units. We have 1, 3, so go to the right 1 and up 3. We have 2, 0, so we go to the right 2 units. And then we have 3, negative 5, where we move to the right 3 units and then go down 5 units. And so connecting this with a smooth curve, we get something of this nature. For each value of x, there's one and only one value of y. If an equation in 2 variables, x and y, yields precisely one value of y for each value of x, we say that y is a function of x. The notation y equals f of x indicates that the variable y is a function of x. This is not f times x, it's read f of x. So it's a function of x. And so what this means is the variable that's inside the parentheses is what we can plug into, just like what we did for example number 2. It's just a little bit different with the notation. So let's go ahead and find f of 4 for f of x equals 2x plus 3. Since x is our variable, everywhere we see an x, we're going to plug in 4. So f of 4 is 2 times 4 plus 3, and then we want to work with order of operations. Well, 2 times 4 is 8, and 8 plus 3 is 11. Let's look at g of negative 2 when g of x is 2x squared minus 1. So again, wherever we see x, we're going to plug in negative 2. That's 2 times negative 2 squared minus 1. We want to evaluate the exponent first, and negative 2 squared is 4. Well, 2 times 4 is 8, and 8 minus 1 is 7. Let's go ahead and try another one. H of negative 5. This time it's h of r, but as you can see, the function is in terms of r. So it's just letting you know where you're allowed to plug in. It's placeholders. So we have negative 5 cubed minus 2 times negative 5 squared plus 5. Let's go ahead and do our exponents first. So negative 5 cubed is negative 125. Negative 5 squared is 25. And then let's look at our multiplication. So negative 2 times 25 is negative 50. Negative 125 minus 50 is negative 175. And when I add 5 to that, I end up with negative 170. So for example number 4, tailgaters beware. If your car is going 35 miles per hour on dry pavement, your required stopping distance is 160 feet or the width of a football field. At 65 miles per hour, the distance required is 410 feet, or approximately the length of 1 1/10 football fields. Figure A on the left shows stopping distances for cars at various speeds on dry roads and on wet roads. Figure B on the right uses a line graph to represent stopping distances at various speeds on dry roads. Use the line graph to estimate a car's required stopping distance at 60 miles per hour on dry pavement, and we want to round to the nearest 10 feet. So am I giving you x equals 60 or y equals 60? So looking at the graph, on the horizontal line, it tells you that this represents the speed in miles per hour, while the y-axis is labeled as the stopping distance in feet. Since we're given that we are driving at 60 miles per hour, this is x equals 60. And we need to figure out what y is, or what the stopping distance is that is required. So looking at our line graph, we want to look at x equals 60 and see what value of y we have on the graph. So we want to travel up our vertical line until we hit our graph. And so let's see what y value is paired with our x equals 60. So it looks like it's between 300 and 400, almost halfway. So I'm going to say that it's about 350 feet. And that is what is required to stop when we're traveling at 60 miles per hour. Now the function f of x equals 0.0875x squared minus 0.4x plus 66.6 models a car's required stopping distance f of x in feet. So this is like our y that we looked on our graph earlier. And x is the miles per hour. We want to use this function to find what the actual required stopping distance is and round to the nearest foot. We were able to estimate using the graph, but I want to know what the actual distance is. So we want to plug in x equals 60 into our function. So what we're doing is we're finding f of 60. So that's 0.0875 times 60 squared minus 0.4 times 60 plus 66.6. And so doing our exponents first, 60 squared turns into 3,600. And now we want to do multiplication. So 0.0875 times 3,600 is 315. Negative 0.4 times 60 is negative 24 plus 66.6. 315 minus 24 plus 66.6 gives me 357.6 feet. So our estimation was pretty good at about 350, but the actual answer is 357.6 feet. And if we round to the nearest foot, we would round this up to about 358 feet. The graph of a function is the graph of its ordered pairs. So for example, number 5, we're going to graph f of x, which is 2x, and g of x, which is 2x plus 4, in the same rectangular coordinate system, and we're going to be selecting integers for x from -2 to 2. So this is going to work just like the one we did earlier, except this time we don't have as many x values. We're looking at -2, -1, 0, 1, and 2. And we're going to do this twice. We're going to do it for f of x, which is 2x. And then we're also going to do it for g of x, which is 2x plus 4. So plugging in -2, we have 2 times -2, which is -4. And so our ordered pair is going to be -2, -4. 2 times -1 is -2. And so we end up getting the point -1, -2. 2 times 0 is 0. So we have the ordered pair, 0, 0. We have 2 times 1, which is 2. And so we get the point 1, 2. And we have 2 times 2, which is 4. So we have the point 24. Let's go ahead and plot these points first, and then we'll look at g of x. So I'm going to use purple to show f of x. So we have -2, -4. We have -1, -2. We have 0, 0. We have 1, 2. And we have 2, 4. Now let's go ahead and do this with g of x, which is 2x plus 4. So we have 2 times negative 2 plus 4, and that's negative 4 plus 4, which is 0. So we have the point negative 2, 0. We have 2 times negative 1 plus 4, which is negative 2 plus 4, or 2. And so we have the point negative 1, 2. We have 2 times 0 plus 4, which is 0 plus 4, or 4. So we get the point 0, 4. We have 2 times 1 plus 4, or 2 plus 4, which is 6. And so we get the point 2, 6. I'm sorry, 1, 6. And then we have 2 times 2 plus 4, which is 4 plus 4, or we get 8. And so we end up getting 2, 8. And so I'm going to plot this in blue. So we have negative 2, 0. We have negative 1, 2. I have 0, 4. 1, 6, which I'm going to go off the graph here a little bit. And then we have 2, 8. Not every graph in the rectangular coordinate system is the graph of a function. The definition of function specifies that no value of x can be paired with 2 or more different values of y. So we have a test to see if graphs are functions, and it's called the vertical line test. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So all you have to do is draw a vertical line on the graph, and if it hits more than one point on the vertical line, then it's not a function. So looking at the first one, you can see that I'm hitting 2 points on both of these. Even if I draw a vertical line at the end, where I'm only hitting 1 point, it still failed on my other lines, which means that this is not a function. Let's go ahead and try the next one. If I were to draw a vertical line on this graph, anywhere, you'll see that I only ever hit 1 point. So because I only hit 1 point, this is a function. Let's go ahead and try another one. When I draw a vertical line anywhere on this graph, I am only hitting 1 point. And so this is a function. And one more. If I draw a vertical line on this graph, although I only intersect at 1 point at the leftmost, I intersect 2 or more points on other vertical lines, which means that this is not a function. It only has to fail on one vertical line to fail the entire test. And let's try one more. For example, number 7, it's too late for that flu shot now. It's only 8 a.m. and you're feeling lousy. Fascinated by the way that algebra models the world, you construct a graph showing your body temperature from 8 a.m. through 3 p.m. You decide to let X represent the number of hours after 8 a.m. and Y represent your body temperature at time X. We're going to use the graph to answer the questions below. What is the temperature at 8 a.m.? So remember that the x-axis is the hours after 8 a.m. So 0 hours after 8 a.m. would be 8 a.m. One hour would be 9 a.m. 2 hours would be 10. 3 hours is 11 a.m. 4 hours is now 12 p.m. 5 hours is 1 p.m. 6 hours is 2 p.m. And the 7th hour is 3 p.m., which is when he said that they were going to stop taking the temperature from 8 to 3. So now that I've labeled this, it'll probably make this a little bit easier to read. So what is the temperature at 8 a.m.? I'm giving you X, and you need to tell me Y. So X equals 0. What is the Y value? Well, if you look on the graph, it's 101. And so your temperature would be 101 degrees Fahrenheit at 8 a.m. During which period of time is your temperature decreasing? So that means when it looks like you would be able to slide down the graph. And so that's from 8 a.m. until 11 a.m., where then it starts to increase again, or from x equals 0 to x equals 3. So your temperature is decreasing or dropping from 8 a.m. to 11 a.m. Let's estimate your minimum temperature during the time period shown. How many hours after 8 a.m. does this occur, and at what time does this occur? So the minimum is going to be the lowest point on the graph, and we want to estimate it. And so the lowest point on the graph is where x is equal to 3, and it's in between 98 and 95. So I am going to estimate that it's about 98.5. This happens 3 hours after, because x equals 3, which is 11 a.m. During which period of time is your temperature increasing? So this is the part of the graph that looks like you would have to climb up it. And that's from x equals 3 to x equals 5. And so that's from 11 a.m. to 1 p.m. Now, part of the graph is shown as a horizontal line segment from 5 to 7, x equals 5 to x equals 7. What does this mean about your temperature and when does it occur? So what this means is that your temperature is constant, it doesn't change. And this is from 1 p.m. to 3 p.m. So from 1 p.m. to 3 p.m. your temperature stays at 100 degrees, it stays constant. And then explain why the graph defines y as a function of x. So if you think about it, one, it passes the vertical line test, but this is talking about time and my body temperature. There's no way that I can be two body temperatures at once. So each hour can only yield one body temperature.